In this video, we're going to talk about reflections. Reflect triangle ABC over the x-axis. So you can see here we have triangle ABC, and we have here the x-axis. So what does it mean by reflect? So essentially with a reflection, we're going to flip this shape over top of this line right here, and we're going to have an image on the other side. So what's a way that we can do a reflection? Well, the easiest way to do a reflection over horizontal or vertical axis is to simply count the distance between your points and the axis that you're flipping over. So if I start with point B here and I count, I got 1, 2. So I'm going to count 1, 2 to the x-axis, and then I'm going to count another 1, 2 on the other side. 1, 2. And here I will find my new B. This will be B prime. Now I can do the same thing for A and C. Count 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this should be my new A prime. And for point C, 1, 2, 3, 4. 1, 2, 3, 4. Here's my new C prime. And then I simply have to connect the dots. Now you can kind of visualize here, if I had this drawn on a piece of paper and I folded that piece of paper along this x-axis, that's the image I would get on the other side of the piece of paper. Maybe I put some ink here and I folded it, and this is the image that would be created on the other side of the piece of paper. So that's a reflection. So reflected over the x-axis. Okay, so that would be this axis right here, and it's labeled for you usually on your Cartesian plane, x-axis. Let's do another one. Reflect triangle ABC over the y-axis. So this time I'm reflecting over the y-axis. Here's the y-axis right here, the y-axis. Same strategy I can use. If I want, I can simply count from A to the y-axis is 1. So I count another 1. So there's my new A. This is A prime. For B, I count 1, 2, 1, 2. There's my new B, B prime. And for C, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There's my new C prime. So I can draw that right there, and there's my reflection over the y-axis. But let's for a second have a look at what our coordinates are, because this isn't the only way that we can do this. So if I click on this image right here, what I can do is I can actually show the vertice points here. So we have, if I make a table of values now real quick, my original triangle, I have the point A, and that is 1, negative 5. And I have the point B, which is 2, negative 2. And I have the point C, which is 5, negative 4. So let's have a look and let's see what's happening to my points as I do a reflection. And actually in Smart Notebook I have a handy dandy little tool here. So what we're going to do is we're going to reflect this. Okay, so we're going to reflect that, and we're reflecting that over the x equals 0. Okay, so there we go. So what's happened to my points here? My new image, so this was ABC, B, C. So we're going to call these x prime, y prime. My new A, which is right here, is the point negative 1, negative 5. Negative 1, negative 5. My new B is the point negative 2, negative 2. And my point C is the point negative 5, negative 4. Notice that when I reflected over the y-axis that none of my y values actually changed. And my x values, what happened to them? Well, here I have positive 1, 2, and 5, and here I have negative 1, 2, and 5. So essentially, another way to do this is to write out a table of values, and then you can write out my other table of values, and then I just negate all my x values and leave all my y values the same. That's if I'm reflecting over the y-axis. If I were to go back to our previous problem, we could do the same thing. Let's have a look. What happens when let's show the vertex points here, and let's reflect this. This time we're reflecting over the y equals 0. Okay. Now actually what I'll do is I'll erase my drawing there. So there we have it. Let's have a look at the points. What do I have? I have my original A, B, C, X, Y. My original points were 1, negative 5, 2, negative 2, 5, negative 4. What are my new points? We'll call these X prime, Y prime. My new points are 1, 5, 2, 2, and 5, 4. This time, notice that all my x values here are the same. It's the y values that have changed. So what's happening to the y values? Well, these started off as negative and then they became positive. So another way to do these reflections, if I'm reflecting over the x-axis, well, I'm just going to keep my x values the same. My y values are going to be negated. And I can create a table and then plot the points from the table. So let's maybe try an example like that. And what I'll do is I'll move this shape around. Let's get rid of this. Okay. And let's just move this shape over here like so. And we're going to do the same reflection. This time, though, we're going to use a table of values. Let's move that over there so I can see the coordinate nice. Okay, there we go. So my original table is going to be, and we'll have to move these letters here. So I got my triangle ABC. Label those like that, like so. So my point A is negative 4, negative 4. My point B is negative 2, negative 5. My point C is negative 2, negative 2. So if I just wanted to use a table of values to solve this problem, what I say, I'm reflecting over the x-axis, so I'm going over this axis, so none of my x values change. My x values stay the same. I'll call that negative 4, negative 2, negative 2. And what happens to my y values? I said they become negated. So negative 4 negated is going to be positive 4, negative 5 negated is going to be positive 5, and negative 2 negated is going to be positive 2. So here are my new points. So I have negative 2, 2, negative 2, 5, and I have negative 4, 4. And there's my reflection. I can confirm that by simply reflecting that shape over the y equals 0 axis. There we go. There it is. Okay, and there are, as you can see, my coordinates. So, two ways that you can do this when you're reflecting over the x-axis. I can either count the distance, right? So I go 1, 2, 1, 2. Or I can create table of values, keep the x values, negate the y values for the if I'm reflecting over the x-axis. If I'm reflecting over the y-axis, I can keep the y values the same, and I negate the x values, or I can just count, right? I can just count the distance from the y-axis. Let's have a look at last example here. Reflect triangle ABC over the y equals x-axis. I'm going to start off by showing you how to do this with the distance. This time, we're going to move on a diagonal. Okay, so we're going to move using the vertices. So if I start from A, I move diagonally 1, 2, 3. I'm going to move to that. So that's 3 diagonal units to the line of reflection. I'm going to move another 3, 1, 2, 3 on the other sides. Over on the other sides, let's move my new A prime. For B, I move 1, 2, 1, 2. Here we go. There's B. My new B, B prime. And for C, 1, 2, 3, 4 and a half, right? So, and then we're going to go 1, 2, 3, 4. Is that a half? 1, 2, 3, 4 and a half. Yeah. There's my half. Sorry. 1, 2, 3, 4. So we're going to be right here. Okay, so this is my new C, my C prime. All right, and there I have my new triangle. So how can I do this with a table of values? Well, first of all, what are my coordinates? So let's just set this up. Let's show my vertex points here. Okay, I have A, B, and C. So I have my points X, Y. So A was, again, 1, negative 5. B, 2, negative 2. And C, 5, negative 4. So what are my X prime, Y prime coordinates? Well, my A, point A, my A prime is going to be negative 5, 1. Negative 5, 1. My B prime is negative 2, 2. Negative 2, 2. And my C prime is going to be negative 4, 5. Negative 4, 5. Well, look what happened here. These are all the same numbers. They just switched places. So if I wanted to do a reflection over the y equals x-axis, I could start off with a table of values and then just switch the coordinates for my new table. So let's give that a shot. Let's do a new problem. Real quick, we're going to use the second method here with a table of values. So I'm going to move some of these dots around here. Let's move this one maybe over here. We'll move this one here. We'll move this one over here. We'll put that one there. There we go. Oh, off there. Okay, so table of values. Here we go. I have X, Y. Oh, I have to move my labels here too. A, B, and C. Okay. So my point A is going to be 2, negative 1. My point B is going to be 4, 2. And my point C is going to be 6, negative 2. So what did I say we do with the table of values? Real easy. X prime, Y prime. I'm reflecting over the Y equals X axis. I simply switch places. I put the negative 1 here and I put the 2 here. I put the 2 here and I put the 4 here. I put the negative 2 here and I put the 6 here. So let's plot these points. What do I have? I have negative 1 and 2. I have 2 and 4. 1, 2, and 1, 2, 3, 4. And then I have negative 2 and 6. 1, 2, 3, 4, 5, 6 here. Okay, and there is my triangle. Should be able to confirm that by reflecting this shape over the y equals x-axis. Oops, did we miss one? Dun, dun, dun. Oh, the graph moved on me. That's why. That wasn't the right spot. The graph grew when I hit the reflection. Okay. So don't worry, we did it right. And that is that's reflections.